In the last video, we found out the technical rate of substitution for a CES production function. In this video, let's find out the elasticity of substitution for a CES production function. Same as last video, assume that we have a CES production function, y is some function of labor in capital is equal to AL to the power of rho plus BK to the power of rho and whole to the power of 1 over rho. And for make it simple, assume that A is equal to B equal to 1. Then Y will be equal to L to the power of rho plus K to the power of rho whole to the power of 1 over rho. So now let's find out the elasticity of substitution for this CES production function, for this one, for this simplified version. And we have the formula for elasticity of substitution, which is equal to derivative of logarithm or natural log of K over L divided by or with respect to ln of TRS. Derivative of ln of K over L with respect to ln of TRS. And in the last video, we found out the technical rate of substitution in absolute form is equal to K over L whole to the power of 1 minus rho. So in order to find out the elasticity of substitution, we need the logarithmic form of TRS and logarithmic form of K over L. So in order to find out the logarithmic form, let's take the natural log of each side. Let's transform it to the logarithmic form. So then we will have ln of TRS in absolute value will be equal to 1 minus rho multiplied by ln of K over L. Ln of K over L. Actually, we need to take the derivative of ln of K over L with respect to ln of TRS. So in this case, to make it simple, so let's move then 1 over rho to this side and just have ln of K over L here. So then it will be equal to ln of K over L is equal to, then when we move this one to this side, or if we divide both sides to 1 over rho, both sides to 1 over rho, then here it will be 1 divided by 1 over rho multiplied by ln of absolute value of technical rate of substitution. Absolute value of technical rate of substitution. Now it's easy to find out this formula. So take the derivative of ln of K over L with respect to ln of TRS. So then derivative of ln of K over L with respect to ln of absolute value of TRS. Then if we take, so this one, the power is 1, so it will move out, so we will remain with 1 divided by 1 over rho. So now we know that the derivative of ln of K over L with respect to ln of TRS is equal to what? Elasticity of substitution. And this is in this simplified version of CS production function is equal to 1 over 1 minus rho. Then finally, the elasticity of substitution for the CS production function is equal to 1 divided by 1 over rho. So now we know that the elasticity of substitution for this CS production function is what? Is constant. Why? Because it's dependent on the value of rho. Rho is a constant number. Rho is a constant number. Then this production function has a constant elasticity of substitution. That's why it's called constant elasticity of substitution production function. You can know it from its name. Constant elasticity of substitution. That's why elasticity of substitution for this production function is just a constant number, is equal to 1 divided by 1 minus rho. Thank you for watching. Hope to subscribe my YouTube channel, like, share your comment, and ask any question you have. See you next time.